Good morning and welcome to NASA's Jet Propulsion Laboratory. Today is L-1, that's landing day -1, and everyone is getting more and more excited as we get closer to the landing of the Mars Curiosity rover tomorrow at 10:31 p.m. Pacific time. I'm going to introduce our panel from the mission team. They're going to explain a little bit more about what to expect tomorrow night, and we'll start with Doug McQuistion. He's from NASA headquarters, and he is the Mars Exploration Program Director. Arthur Amador from the Jet Propulsion Laboratory. He is the mission manager for the Mars Science Laboratory. Steve Sell, also from JPL. He is on the Entry, Descent, and Landing team. Richard Cook from the Jet Propulsion Laboratory. He's the Deputy Project Manager of the mission. And Ashwin Basavada, also from JPL, the MSL Deputy Project Scientist. And we'll begin with Doug McQuistion.
Thank you, Veronica. 1 day, 12 hours, 59 minutes, 45 seconds. Who's counting? Anyway, it gets scarier every day. So I want to start actually with something a little different here this morning. I'm going to start with what's going on with the orbiters. So Odyssey's in good shape. I mentioned at a press conference 2 days ago that it was now in position to collect the telemetry and beam it back to us in a bent pipe mode. MRO started its EDL sequence yesterday. And what I want to show is a quick animation of what at least MRO is going to go through to cover the MSL entry. So if we can bring this first animation up, what you're seeing is video imaging of MRO. The red vector is the -X of the spacecraft. What's important is the green vector, which is the pointing angle of the HiRISE imager. And you'll notice the spacecraft flops around quite a bit. This is both to keep the sun in line as well as pointing down. You see MSL coming in the pink as it lands, and we're going to attempt to have HiRISE point at MSL in its final phases of descent and get an image of it going down. This is going to be difficult. As you can see, the spacecraft does a lot of gyrating related to gymnastics, if you will, since we're in the Olympic season. But it's a pretty challenging thing that it's doing. The team's worked really hard, and the Odyssey team has worked equally hard on their system. So these guys and gals and their spacecraft are ready to do this. And I really hope we can get this image, but it's going to be tough. We were really lucky on Phoenix getting that one. We'll see if we do it this time. So that's kind of a fun video. Back to MSL. Like all missions, MSL started with something that was pretty scary and pretty risky, and that was called launch. Unlike most missions, we haven't finished the scary and risky stuff yet. MSL still has to put Curiosity on the surface after it goes through the atmosphere. Our 7 minutes of terror, which you'll continue to hear about. So can we do this? Yeah, I think we can do this. I'm confident. The team's done an amazing job. We have the A+ team on this. They've done everything possible to ensure success, but that risk still exists. It's going to be tough. If we're not successful, we're going to learn. We're going to learn from this. We've learned in the past. We've recovered from it. We'll pick ourselves up. We'll dust ourselves off. We'll look at this and do something again. We'll do it again. This will not be the end. Human spirit gets driven by these kinds of challenges, and these are the kind of challenges that force us, drive us to explore our surroundings and understand what's out there, and obviously look at why are we alone. Let's bring up this next graphic. But to tell you how hard this is the scoreboard. We are behind. Mars has been winning. The global success rate is about 40%. This is orbiters, landers, flybys, etc. So it's tough. This is the most challenging landing we've ever attempted. So we'll see how this goes. We're all looking forward to it. I'm confident. I'm proud of this team and what they've done, and I'm proud of their readiness. It's pretty exciting. So at the end of this little talk on Phoenix, I quoted a Rolling Stones item. So to continue that tradition, at this point, I'm using Tom Petty today. So we're learning to fly, and we don't have wings. Getting down is the hardest thing. With that, over to Arthur.
No problem. Okay. My name is Arthur Amador. I'm the MSL Cruise EDL Mission Manager, and I'll give a quick summary of our current status, recent events, and upcoming operational activities. So regarding our current status, we're at entry minus 36 hours. The spacecraft and ground systems are all healthy and performing as expected. The spacecraft is now in the EDL approach configuration. In our final approach orientation, pointing our medium gain antenna within a degree of the Earth, we've got a strong telecom signal receiving data at 2,000 bits per second over the DSN antennas of Madrid as we speak. The power subsystem is healthy. Our rover batteries are charged to 100%. The thermal and propulsion systems are nominal with stable temperatures and pressures, and the DSN continues to perform well, tracking the spacecraft continuously and conducting 2 differential ranging passes per day. Can I get the graphic, please? So with a little under 4.5 million kilometers to go to reach Mars, we've traveled now 560 million kilometers around the sun since launch 8 months ago. And we're now right on target to fly through the eye of the needle. That is our target at the top of the Mars atmosphere. The target is a box that's 3 kilometers by 12 kilometers in dimension. And we're flying right through it. Okay, thank you for that graphic. Events over the last few days on the spacecraft have been nominal and quiet, as nominal and quiet as we could have hoped for. The spacecraft has been under the autonomous control of the onboard EDL sequence since Monday evening and has been executing its actions as planned. Our trajectory inbound to Mars has been right down the pipe, so we canceled last night's opportunity to perform our 5th trajectory correction maneuver. During the hours that we have left here before landing, the flight team will remain vigilant, monitoring and assessing the health of the spacecraft and tracking its trajectory and preparing any necessary changes to guidance and entry parameters. We have several opportunities to make final parameter updates, 1 today and 2 additional opportunities tomorrow if we need them. We have 1 more significant activity to perform with the spacecraft late tonight, and that's to command the final enable and activation of the contingency software on our backup computer. The team's confident and thrilled to be finally arriving at Mars. And we're reminding ourselves to breathe every so often. Our system's in place, and we're ready to go. So I'll pass it on to Steve Sell and the EDL team.
Good morning. My name is Steve Sell. I'm on the entry, descent, and landing team here at JPL for Curiosity, and like Arthur, I just have to keep reminding myself to keep breathing. Only got 36 more hours to go. And so I just want to walk everyone through what we can expect to see and hear tomorrow night as we go through entry, descent, and landing. As you remember, because we've probably been talking about this for quite a bit over the past few days, there's several different phases of EDL. And at first we enter the Mars atmosphere. We're going about 13,000 miles an hour when we do that. And as we slow down with the initial drag on the atmosphere, that's what we call the entry phase, and during that time we're doing our hypersonic guidance maneuvering, so we're basically carving back and forth through the atmosphere to control how fast we're slowing down to get ready to deploy the parachute at about 1,000 miles an hour, and then we're on the parachute for a while until we get a good radar solution on the ground. Once we get that radar solution on the ground, we wait until we're about a mile off the ground, and then we cut free from the parachute, do our powered descent, and finally ending in the wonderful sky crane maneuver where we lower the rover on 3 bridles underneath the descent stage and set it gently on the ground, and the descent stage then flies away to a safe landing about 500 meters or so from where we placed the rover. So, like you all, I'm going to be, eyes peeled to the monitors for this whole thing, and so I just want to tell you how we're going to be watching this. And we actually have 4 different ways that signals are coming back to Earth, and so there's a lot going on here. I'll try my best to explain it pretty clearly. Just thought at first I would point to some things on the spacecraft here that are of interest for the communications during entry, descent, and landing. The first is this antenna that's tilted out the side of the parachute cone here. That antenna will be transmitting on the X-band, and I'll get into that in a little bit, but that will be transmitting tones back to Earth, and we've We've used those in past missions. And there's an antenna that wraps all around the parachute cone here, and that will be transmitting on the UHF frequency, and that will be transmitting data back to Earth, or to the relay orbiters that Doug mentioned before. So the tones are basically a series of beeps from the spacecraft. We don't actually hear them as tones in the control room. We actually just see them appear as numbers on the screen, but there's no actual information or data transferred in those tones. They're just markers of I've gotten this far in the entry, descent, and landing sequence. The UHF is a more rich data set. Then we can actually send numbers back, so we get things like altitudes and velocities, positions, and more rich data like that. So how this will play out on EDL night, tomorrow night, we actually have a unique timing where we've tweaked the orbits of the Odyssey spacecraft and the Mars Reconnaissance Orbiter so that they will pass over the landing site as we're landing there, and we'll use both of those to relay our UHF data back at different timescales, and I'll get into that in a second. But if we could bring up the first video, this demonstrates the sequence of events as we're approaching Mars. You can see MSL there with its leaving a little trail as it's coming in. So Gale Crater appears on the right of the screen. You'll see it marked there. So this is coming in from the west to the east, and you'll see MRO will pass over the landing site from the south to the north, and you'll see Odyssey come in from the north to the south. You'll see it in a second, and MSL is just about landing. It touches down almost when MRO is directly overhead, and Odyssey is passing off a little bit more to the east. So that's the timing that we're using to cover entry, descent, and landing. And the way we're using both of those spacecraft is Odyssey is operating in what we call a bent pipe mode, which allows us to relay data back to Earth in real time. So that's what we're going to be glued to on the computer screens. Everybody's going to be watching that, and we're using that to drive some pretty cool animations that will show the telemetry in graphical form as it comes back. So you'll actually see pictures of the capsule and the parachute and stuff like that, and we'll actually be able to watch the telemetry in a meaningful way as it's descending. The tones actually will start transmitting those about 10 minutes before entry into the atmosphere, and those tones are direct to Earth, so they do not get relayed through the orbiter. The tones will keep being emitted by the spacecraft all the way down to until we're on the parachute. At that point, the Earth actually sets from view of the spacecraft, and so we will no longer be able to receive the tones. Although the spacecraft will still be sending them, we're kind of blocked from view. However, Odyssey passing overhead will still continue to relay that high, rich data set back to Earth all the way through touchdown and for a few minutes after touchdown. In addition to the tones and MRO and Odyssey, we will also be making use of the European Mars Express spacecraft, which will be recording the UHF signal, and it will send what it hears back to Earth several hours after landing. And I know there's a lot of stuff going on here, so we put together a little video to try to help explain the sequence of the different timings. So if we can have the second video, please. You'll see the spacecraft entering there, emitting the Aquaman UHF tones and the little magenta or pink the pink tones, they're direct to Earth. And you can see MRO and Odyssey passing over the capsule as it's landing, and when Odyssey gets into view of the UHF, it then relays that back to Earth. And MRO will record that UHF data and play it back a couple hours after landing. And there you see the DSN receiving that information for us to view here at JPL. And so, as I said, we expect to have the Odyssey vent pipe relay to us all the way through touchdown, through several minutes after touchdown. And then at approximately an hour and a half after landing, Odyssey will replay that data again back to Earth, everything it heard, just as another way of getting the data back again.